Python namespace and scope. In this lecture, we'll talk about names, namespaces, variable scope, and take some examples. A name in Python is an identifier, a label by which to call an object. And in Python, everything's an object. The ID function returns an object's identity, which is unique and constant for its lifetime. Say A is 2. Its ID is this. We increment A by 1. A is now 3 and its ID is now this. A new variable B is 2 and its ID is this. So this must mean it has one object that is 2. Its ID remains the same. What variable we store it in does not matter. The values 2 and 3 have these IDs. Let's figure out what's happening. A is 2. We increment it by 1. Now 2 is an object in Python. That's okay. But now we also have the object 3. And A is now 3. And now B is 2. We have objects 2 and 3. A is now 3. And B is now 2. This means names are bound in Python as the program is running. This is dynamic name binding. You can also play around with names. A is 1, but it can now hold the string 1 instead. We can also call the ID function identity instead. So now identity of 2 means a call to ID of 2. And this is the number. And if you understand names, namespaces are simple. A namespace is a collection of names, a mapping of names to the objects they hold. And this is implemented as a dictionary. You can also call it a context. Having multiple namespaces reduces the chances of name collisions. We have 3 levels of namespaces in Python. The local namespace, which is defined by functions, the global namespace, courtesy of modules, and the built-in namespace. These are the names available in the interpreter by default. A variable has a scope. It is that part of code where it's visible. The variable b holds the value 8. A function func sets a to 7, then prints the values of a and b. When we make a call to func, it prints the values 7 and 8. We're done with func. Now print a. And it doesn't print its value but gives us a name error instead. We can't access a from outside func because a is local to func. But we can read b in func because it is global to func. We'll see about that later. Also, a variable's lifetime is the duration for which it is alive, much like your own. We have 4 kinds of scope in Python: the local scope, the enclosing scope, global, and built-in. A is 0. A function func prints it, sets it to 1, then prints it again. When we make a call to func, it raises an unbound local error. We tried to print the value of a when we hadn't even assigned it yet. This a doesn't count because it looks for a local a instead. This one has a as a default argument with the default value of 0. It increments a by 1, then prints it. Make a call to func and it prints 1. In all of this a is global to func and this one is local. A global value is readable anywhere in the program. Now the enclosing scope. This is a function red that sets a to 1, defines the function blue. This sets b to 2 and prints the values of a and b. Red then makes a call to blue and also prints the value of A. We make a call to red and it prints 1, 2 and 1. B is local to blue, but A is non-local to it. It is neither global nor local. The built-in scope has all the names loaded into scope when we start the interpreter. Like the print function is always available to you. This is the widest scope of them all. This is also where the interpreter looks for an identifier if it cannot find it in other scopes. The order of looking for identifiers is LEGB, local, enclosing, global, and built-in. Let's take another example. A is 1. Function func1 sets B to 2 and defines function func2. This sets C to 3. Here, C is local to func2. B is local to func1 but non-local to func2 because it isn't local to it but nor is it global. A is global here. So inside func2, you can read and write C as it's local to it, but you can only read B because it's non-local to it. It cannot modify B. Similarly with A, which is global to it. In this one, A is 1. Function func1 sets B to 2 and defines function 3. In this, A is 2, B and C are 3. It prints their values. Func1 calls up func3 and also prints the value of B. Let's call up func1. A, B and C are 2, 3 and 3. And then outside of the function 3, B is 2. Globally now, if we print A, it prints 1. Now take a look at this one. Function 3 declares that A is global to it and B is non-local. Calling up function 1 prints the same things now, but printing the value of A prints 2. This means function 3 has modified it instead of using its own local variable A. So it seems if we want to modify values while accessing a global or non-local variable, we can declare it so.